So this is Physics Lab 2, which is the motion of a falling object by Isaac Abraham. So the purpose was to analyze the motion of a falling object and the effect gravity and drag have on it. And the equations I used were the momentum principle, which Newton's second law, F equals ma, and F net equals change in momentum over change time, the velocity update, position update, and then the new equation that we got from the instructions was the drag force, which you see on the screen. Then the models was a position versus time graph and velocity versus time graph, and the system was the object in motion, which in this case was a crumpled piece of paper, and the surroundings was everything else. So for the experiment, it was pretty simple. I crumpled up a piece of paper and I recorded a video of me dropping it and uploaded it to Tracker and let Tracker do its magic and just continued on with the code. So for the model, the blue curve is the observed one, which was from the video in Tracker. The red one was without drag, so just only gravity, and then the yellow one is, or the orange one, is with drag, so both gravity and drag. And as you can see, they're all negatively sloped, which makes sense, and they all start at a y position above the origin, because that makes sense, because I remember I dropped the object at an initial height greater than 0, and it like went down to the origin or to the ground, and then the slopes, the yellow and the red, like the slopes of the yellow and the red curve are pretty similar, but and they're from the code, but the slope of the blue one, which was from the Tracker video, is pretty different, and I blame it on Tracker, to be honest. You'll see on the next slide, or the slide after this one. So code, the ball or the mass, I put it as that because I searched up the mass of paper and it said about 4.5 grams. The initial conditions, 0.427 meters was about like the height, and then the velocity was that, and then the thing I changed was the B. So for the red curve, which was without drag, I kept the B as 0 when I did the model, but then went for the orange curve, so the one with drag, I changed it to 0.0077, because you remember you had to guess and check, and then the 0.25 next to the time, where it says while time is less than 0.25, I got that value from the Tracker video. And then on the right, velocity update formula and position update formula. Then possible sources of error. The object didn't fall in a perfectly vertical path. Like what I mean by that is, like, when I dropped it, I couldn't like control exactly how it fell, so it kind of fell to the side a little bit, because it's not gonna be perfect. And then well, like I said, Tracker was kind of acting up. What does it mean? Question. None of my models predict a terminal velocity, but the model with the drag is definitely closer to terminal velocity than the one with gravity. And I say this because the velocity time graph looks like it's leveling off, meaning that the object is approaching that terminal velocity. An object traveling at terminal velocity travels at constant velocity once it reaches that terminal velocity, meaning that the net force is 0. The next question. I feel like the terminal velocity, like the actual velocity, will be about the same. I know it's kind of hard to tell on these graphs, but like it hasn't really reached the terminal velocity in these graphs, but I would assume there would be about the same velocity, no matter if the object was dropped or thrown down. But I believe that for the object that was thrown down, it would reach that terminal velocity quicker, because it's moving faster already. And then conclusion, an object falling in motion reaches terminal velocity or its max velocity when the drag force cancels out the force of gravity acting on the object, and that means that the net force is 0. And thank you for listening.